So last time we talked about the function's increasing or decreasing part. So this time we want to talk about concavity. So let's look at theorem for the 7. So number 1, if f second prime is greater than 0 for all x in I, then the graph of f is concave upward. And if f second prime is less than 0, then it's concave down. The first thing we have to know how or what kind of shape we determine concave upward and concave downward graph shape. So if I show from any curve, this curve looks like this, and this curve, so this one is concave up, this is concave down graph here. So this side here, that is the decreasing concave up, and this one we can indicate increasing concave up. Similarly, this is increasing concave down, this is decreasing concave down here. Okay, the reason we should know this kind of graph, because when you look at a graph shape, the graph will never just increase like this or decreasing like this. It always makes a curve here, such as like this, and then something like that. I mean, like this, something like that, right? Okay, then even here, now you can say this is concave down increasing, and now somehow here is concave up increasing. Make sense? Also, this graph, somehow this is concave down decreasing, and some point is concave down decreasing here. So concave up decreasing, so concave up decreasing, and then concave down decreasing. So likewise, if we know concavity, then we can actually make some graph more smoothly here. Okay, then let's go back to what we have done the last time. So last time we actually just evaluate how this function is increasing or decreasing. So when you look at this function case, this is decreasing and then increasing and decreasing and increasing, but we didn't indicate the exact shape here. I just draw just whatever like this, and just increasing means just going up and then decreasing going down like that, right? Okay, but now because we also talk about concavity, we want to actually draw the graph more accurately. Okay, look at this example here. So finding points of inflection. So determine the point of inflection and discuss the concavity of the graph of fx equal to x to the fourth power minus 4x cubed. Okay, so as we see this theorem, the concavity, to find concavity, we need to do second derivative. Then how to find the second derivative? Yes, you derivative one more time after you did first derivative here. Okay, so let's do it. So f prime x equal to 4x cubed minus 12x squared. Actually, I skipped a step, so but even so, I think now it is time for you to use those shortcuts, and then you should know how to do it. So please practice. Okay, now then with one more times, f second prime x will be 12x squared minus 24x here. Okay, so inflection point exists when f second prime equal to 0. Okay, or undefined, like the first derivative here. So to make them equal to 0. Okay, then what's the common factor? Yes, it is the 12x, so 12x, and then x minus 2 here, then equal to 0. So from here, so 12x equal to 0 and x minus 2 equals 0. So x equals 0 or x equals 2. Okay, now we see when x equals 0 and the x equals 2, this function has concave inflection point. Okay, now then why don't we maybe apply the first and second derivative and then maybe just prism the shape of the graph here. So, and because we have already this first derivative function here, so we can find the critical point and then find the interval where the function is increasing or decreasing, right? Okay, so I'm gonna bring this down. So f prime x 4x cubed minus 12x squared. Let's make them equal to 0 here. Okay, then the common factor is 4x squared and then x minus 3 equals 0, right? So from here 4x squared equal to 0 or x minus 3 equal to 0, so x equals 0 or x equal 3. So now we find the interval x, at the point x equals 0 and x equals 3 there, at the time the tangent lines are equal to 0, so that will be our boundary value. So I'm gonna make some table, the table here. So 0 and 3. Now we can determine where this line is increasing or decreasing based on this line. Okay. So I'm gonna choose maybe few testing value. So left side 0, maybe negative 1. So negative 1, between here 1, 4. Okay, now I'm gonna plug those values into f prime function. So the f prime negative 1, which means 4 negative 1 cube minus 12 negative 1 square, which means negative 4 minus 12, which means negative 16. So this interval is negative. Okay, now f prime 1, which means 4 times 1 cube minus 12 times 1 square, which is 4 minus 12. Oh, this is negative 8. So another negative here. Now f prime 4, which is 4 times 4 cube minus 12 times 4 square, which means 4 times 64 minus 12 times 16. So this becomes 256 minus 192 equal to 64, which is a positive here. Okay, so based on this, now we know the graph is decreasing and decreasing and increasing. Yes. Okay, now we should know which interval is decreasing and then which interval is increasing here, right? Okay, then I'm gonna draw another table for the concavity. Concavity is 0 and 2 here, right? So I'm gonna write here. So 0 and 2. We can choose also testing value, maybe testing value maybe let's say negative 1, maybe 1 and 3 here. Okay, so we plug those values into second derivative function. So what was second derivative function? It was 12x squared minus 24x. Okay, so So x equal to 12, x squared minus 24x. So we plug negative one first, then f second prime negative 1 equal to 12 times negative 1 square minus 24 times negative 1. So it becomes 12 plus 24, which means 36. So this interval concave up. Okay, now you know what, I'm gonna write concave up because it may be confused. Now 1, so f second prime 1 equal to 12 times 1 square minus 24 times 1, which means 12 minus 24 equals now to 12, which means on this interval concave down here. Now 3, so f second prime 3 equal to 12 times 3 square minus 24 times 3 is 12 times 9 minus 72, so equal to 108 minus 72, so equal to 36. So which means here is concave up. Okay, so now I'm gonna maybe combine first derivative result and second derivative result together. Okay, so I just combine these two tables like the same pace here. So until 0 we know that the graph is decreasing, something like this, and then until 3, so 3 is right here, so still decreasing, and then it is after 3 it starts increasing, right? Okay, now after that, using the second derivative, we can fix this line here. Okay, so if you look at this, until 0 it is concave up, decreasing though because it's decreasing, but should be concave up, which means the graph shape must be this. Okay, because that's the concave up graph here, concave up decreasing, and from 0 to 2, so I'm gonna mark 2 right here. It must decreasing but concave down. So we can do somehow like this, right? And from 2 to 3, as we see 3 is merging here, from 2 start concave up. So after 2 here is just concave up, and then now the 3 indicate turning point here, which means even though both are concave up, from 2 to 3 it must be concave up decreasing, after 3 concave up increasing. So I can make, so now here something like this. Okay, so that will be the graph here. Okay.